Hi students, Class 12 Mathematics, Chapter 3 Matrices. What is matrix? A matrix is an ordered rectangular array of numbers or functions. The numbers or functions are called elements or entries of the matrix. We can see one example. A equal to matrix 2, 3, 4, 1, 5, minus 2. Always matrix we will represent using by capital letters A, B, C, anything you can use. Then matrix we will write inside the square bracket. You can see in here 2 square bracket. Inside the square bracket only we will write matrix. Inside the square bracket you can write numbers or functions. Functions means cos x, sin x, x square plus 2x, like that. Any functions you can write. Otherwise any numbers. In here you can see horizontal line, first horizontal line. In first horizontal line 2, 3, 4 I written. That first horizontal line is known as first row. First row. Similarly, second horizontal line we can say that is second row. Horizontal lines are known as rows, first row and second row. In this matrix, you can see 2 rows. Similarly, vertical lines is first vertical line, is second vertical line, is third vertical lines. Then in here 3 vertical lines you can see that vertical lines are known as columns. Is first column, then the second column. In second column elements are 3 and 5. Second column. Then next third column. In third column elements are 4 and minus 2. Third column. In this matrix you can see 2 rows and 3 columns. 2 rows and 3 columns you can see. The next, order of matrix. What is order of matrix? Means number of rows into number of columns. This we can read number of rows. This is by number of rows by number of columns. In here, in this given example, how many rows you can see? You can see in here 2 rows. 2 rows into number of columns. How many columns are there? That is 3. Then order of given matrix. This example is 2 by 3. 2 by 3 is order of this matrix. The next, number of elements. Equal to, in this matrix how many elements you can see. That means how many numbers you can see. 1, 2, 3, 4, 5, 6 numbers you can see. Then using by order of that matrix you can find out number of elements. That means 2 into 3 is 6 is our number of elements. Like that also you can find out number of elements. B equal to, in here I am going to give name B, capital letter B. Then sin x 2, then 4 x square. In here, how many rows are there? There is first row, then this second row. In second row, 4 and x square are elements. Second row. Then number of columns, that also 2. You can see in first column, elements are sin x and 4. First column. In second column, elements are 2 and x square. What is order of this matrix? Order of matrix means number of rows. How many rows? 1, 2 rows. 2 by number of columns. Number of columns means that also 2. 2 by 2. Then number of elements also we can write equal to 2 into 2. Just multiple number of rows, that is 2 rows, number of columns, that also 2. 2 into 2, 4. 4 elements. You can see in here total 4 elements, that is sin x, 2, 4 and x square. The general form of a matrix. Give one name. A equal to matrix A11. First element is A11. Second element is A12. Then A13, etc. A1J, etc. A1N. What is A11? The first one are representing which row? This is first row. Then second one are representing which column? That is first column. Similarly in here, A12 means first row and second column. In here, first row and third column. Similarly, this is first row and third jth column. Then last part, we can see this first row and nth column. Similarly, second row also we can write second row, first column, then second row, second column, A22, second row, third column, A23, etc., A2J, etc., A2N. A2N means second row and nth column. Then somewhere we can write AI1. What is AI1 means? Is ith row and first column. AI2. Ith row and second column. AI3, etc. Aij means ith row and jth column. AIN, AM1, AM2, AM3, AMJ, AMN. This is a general form of a matrix. From here also we can write order of matrix. Order of matrix equal to, in here how many rows are there? 1, 2, 3, like that means you can see M up to M. That is M rows by how many columns? 1, 2, 3, like that. If you count, last number is n. N. The order of this matrix is M by N. From here we can write one general element also. That element is Aij. This element is will consider a general element Aij. Now we can study different types of matrices. First matrix is column matrix. What is column matrix means? A matrix to be a column matrix if it has only one column. We can see one example. A equal to 4, 3, 1. What is the order of this matrix? How many rows are there? You can see in here number of rows, that is 1, 2, 3. 3 rows, and number of columns. This number of columns, only one column. Then we can write order of this matrix, that is 3 by 1. 3 rows and 1 column. 3 by 1. In here you can see only one column. That's why this matrix is known as column matrix. In column matrix you can see only one column. Again one more example. B equal to cos x 2, 4. Then order of this matrix 3 by 1. 3 rows and 1 column. This is also example for one column matrix. Then next 2, 8. What is order of this matrix? How many rows are there? 1, 2. 2 rows and 1 column. 2 by 1. That's also example for one column matrix. Then another one 8, 4, 2, 1. What is order of this matrix? Number of rows 1, 2, 3, 4. By number of column only 1. 4 by 1. This is also another example for column matrix. Then second type is row matrix. A matrix to be a row matrix if it has only one row. You can write some examples. A equal to 2, 4 sin x. In here a number of rows, only one row you can see, one horizontal line. In that row 2, 4 sin x, only one row. Number of columns 1, 2, 3. 3 columns you can see. 1, 2, 3. 3 columns and only one row. That is example for one row matrix. Again one more example we can see. 3, 4. In here number of rows only 1 and number of columns 1, 2. Order of this matrix is 1 by 2. Then this is also example for one row matrix. Then 2, 4, 8, 1. In here a number of rows only 1. You can see only one horizontal line. Then number of columns 1, 2, 3, 4. This is also one example for row matrix. Then in column matrix we can see only one column. Only one column. In row matrix, second matrix, in row matrix you can see only one row. Only one. Then next type of matrix is square matrix. A square matrix in which the number of rows are equal to the number of columns. Rows are equal to the number of columns. One example. A equal to 2, 4, 8, 3. In here, number of rows, that means horizontal line 1, 2, by number of columns 1, 2, vertical lines. In here, number of rows to number of columns are 2, both equal. That's why this is the example for one square matrix. What is square? You know, this is like one figure. This is one square. In here 4 centimeter means this side also 4 centimeter, this also 4 centimeter, this also 4 centimeter. All the sides are equal, then only we can say that is square. All the sides are equal, isn't it? Similarly, in here, number of columns and number of rows are equal means we can say that is square matrix. Again, one more example. In here, number of rows 1, 2, 3 by number of columns, that also 1, 2, 3. 3 by 3, isn't it? Then this also example for one square matrix. Square matrix means number of columns and rows are equal. The next type, a diagonal matrix. A square matrix is said to be diagonal matrix if its non-diagonal elements are 0. In here, we will consider only square matrix. Example, A equal to 2, 0, 0, 0, 4, 0, 0, 0, 9. Number of rows, how many rows you can see? 1, 2, 3. 3 by number of columns, that vertical line 1, 2, 3, that also 3. 3 by 3. This is example for one square matrix, that means number of rows and columns are equal. Then you can see in here only diagonal elements are some numbers, other all elements, non-diagonal elements are 0 only, isn't it? Other numbers you cannot see, only zeros you can see, non-diagonal elements. Then this matrix is known as diagonal matrix. One more example we can see, 2, 0, 0, 8. Order of this matrix is 2 by 2, 2 rows and 2 columns. Then in here this diagonal elements 2 and 8 you can see, other elements are zeros, isn't it? Then this is known as diagonal matrix. Next type of matrix is scalar matrix. A diagonal matrix is said to be scalar matrix if its diagonal elements are equal. Example, in here we will consider diagonal matrix. Diagonal matrix means diagonal elements are some numbers, other non-diagonal elements are 0. 4, 0, 0, 0, 4, 0, 0, 0, 4. Diagonal elements. Look, this is our diagonal elements. What is order of this matrix? How many rows? We can see 1, 2, 3. 3 by how many columns? 1, 2, 3. 3 by 3. This is one square matrix only. Then as well as one diagonal matrix, because non-diagonal elements all are zeros. Then in here diagonal elements you can see all the numbers are same, 4, 4, 4. All the diagonal elements are same. Then this type matrix is known as scalar matrix. Again one more example we can see, 2, 0, 0, 2 is our diagonal elements. Order of this matrix is 2 by 2. Non-diagonal elements are 0, then all the diagonal elements are equal, 2 and 2. all equal. That's why this is known as scalar matrix. Next type matrix is identity matrix. A square matrix in which elements in the diagonal are 1 and rest are all 0 is called an identity matrix. We will use capital letter I only. Matrix 1 0 0 0 1 0 0 0 1. In here, diagonal elements, all the diagonal elements are 1, then other non-diagonal elements are 0. Then there is the example for one identity matrix. Then what is order of this matrix? You can see 2 rows and 3 columns. Then we can write I3. Similarly, if you write I2 means order of this identity matrix is 2 by 2. 2 columns and 2 rows. Then 1 0 0 1. In here also you can see diagonal elements are 1. The last type is zero matrix. A matrix is said to be zero matrix or null matrix if all its elements are 0. Example, O equal to 0 0 0 0 2 by 2 order. This is the example for one zero matrix. Zero matrix will represent by O. And then another one 0 0 0 0 0 0. This is also example for one zero matrix. Order is 2 by 3. 2 rows and 3 columns. In here, in the case of zero matrix, no need any square matrix. We can write any matrix. Then only one condition, all the elements should be zeros. The next, equality of matrix. Two matrices A and B are equal when they are of the same order. Each element of A is equal to the corresponding element of B. You can see one example for that also. A equal to 2, 4, 8, 9. Then second matrix B equal to 2, 4, 8, 9. What is order of first matrix? That is A matrix. 2 rows and 2 columns. 2 by 2. Then order of second matrix, that is B matrix, that also 2 by 2. Then order of the both matrices are equal 2 by 2. And then corresponding element. In here first element is 2. In second matrix first element also 2. Then second element, that is 4. In here also 4. Then in second row and first column, that is 8. In here also second row and first column 8. Then second row second column 9. Element in second row second column, that also 9. All the elements are equal. That's why we can write A equal to B. Then another example, two matrices CH-3 to 1. Then D X-Y to 1. In here order of this matrix 2 by 2, 2 by 2. Then all the elements are equal. X you can see in here also first element is X. Then Y, second element is Y. Then 2, 1, 2, 1. Everything equal. That's why we can write C equal to D.